Hi, good morning. Good morning, everyone. I see that we do have a few attendees or participants that have joined this meeting. What we're going to do is just give it a couple minutes for people to log on. Some people have a bit of troubles accessing Zoom. There's a whole buttons to click. A lot of this remote connections are new to a lot of us as well. So we'll probably start a couple minutes after 9, 3 or 4 minutes after then. Okay, so I see we have a couple more participants that have joined. We'll give it maybe 2-3 more minutes. In the meantime, how is everyone doing? I hope everyone is fine. They have their cup of coffee ready before we get into this presentation. So if you guys are unaware, there is a little chat box. Feel free to communicate in there, even to talk to other people that are attending. It's a good platform to bridge relationships and even business relationships. That's where we can use a bit of Zoom. Okay, everyone, I'm going to kickstart the session. I think that's sufficient time for everyone to log on to Zoom. So let me begin. Hi, good morning. Welcome and thank you for attending today's presentation on sales and design. I am Yashin Noren, a modern applications engineer working mainly in the manufacturing workspace, utilizing the core applications Inventor Professional, Fusion 360, and AutoCAD Electrical. Two of these applications actually form part of today's presentation. The topics for today's session will be focused on sales in design. We will first look at how Inventor can be leveraged to improve sales opportunities through design automation. This will include an overview of all the design automation aspects the software has to offer. Then we'll take a quick look at some of the new features AutoCAD Electrical has to offer with this year's release, followed by a demonstration of AutoCAD Electrical using the application to assist in producing a BOM for quoting. To end off, we'll have a short Q&A session. Sales and design begins with design automation. Design automation is about designing your concepts and ideas more efficiently, allowing us to get more done in less time, automate small repetitive tasks, win more bids, and reduce the time to manufacturing by streamlining our design process. All of this can, of course, be achieved with the help of Inventor. The first level of design automation begins at the front end of Inventor, starting the design process with parametric modeling and incorporating formulas, constraints, and rules are all key aspects that allow for intelligence to be built into our designs and ensure that the proper design intent is followed. You may of course ask, what is design intent? Design intent simply implies when changes are made, the design will behave exactly as expected, enabling you to predict how your parts and assemblies will function. Parametrics and achieving design intent assist in the creation of flexible models. When combined with iLogic technology, which we'll speak about later in the session, a new level of automation can be achieved for rapidly reconfiguring your parts and assemblies. The second level of automation in Inventor can be achieved by using the many specialized tools or environments that it has to offer. The plastic parts environment offers features that are specifically designed to make modeling faster, such as boss features for fasteners, snap features for parts that fit together, and many more. Inventor's notorious sheet metal tools enable you to build components with the material and fabrication process in mind. Your sheet metal designs are controlled by industry standards for bend allowances, corner reliefs, and more to ensure the flattened model accurately represents the finished product. Furthermore, flat patterns are generated with a simple click, and you can export them in multiple formats for downstream use. The tube and pipe, along with the frame design assembly environments, are bundled with comprehensive libraries that meet industry standards. These libraries contain all the necessary cross-section profiles and piping hardware that can be easily placed or routed on a simple wireframe structure. These unique tools provide you an opportunity to describe your model or build intelligence into it so that any changes made will propagate to downstream applications like drawings, analysis, and CAM toolpaths, all of which will update according to your modifications to the geometry. Let's have a look at one of these specialized environments in action. The others will, of course, be just as intuitive.
The nature of structural frame design with standard frame profiles and corner treatments makes a relatively simple yet tedious modeling task that's perfect for automation. Autodesk Inventor makes frame design simple, with tools specifically created to make inserting frame members, applying end treatments, and analyzing the performance of frames fast. Let's take a look. Starting with parametric skeleton geometry for the frame, you can begin inserting frame members by specifying the family, size, and material from a library containing thousands of standard profiles. Inventor gives you complete control over the placement of each member. Pick sketches, edges, or points to position your frame members, with options to offset or rotate the frame member profile relative to the geometry selected. Once the size and placement of the frame members are determined, the frame members are inserted into the assembly and automatically numbered based on your preferred file name and part numbering scheme. As you add more frame members into the design, corner treatments can be used to trim, miter, or create notches between members, and end caps can be inserted from the content center to terminate free ends. The standardized nature of frame design also makes it easy to set up and perform structural analysis to make sure your design performs as required. Just add your constraints, for example where the frame is fixed to the floor, and you can start specifying where the loads will be applied. Loads could be applied as point forces, axial moments, or continuous loads across the length of the frame members. The solve time for frame analysis is super quick, so you can immediately begin reviewing displacement and stress results to determine if further design refinement is required. With automated commands for designing structural frames and a simple to use analysis environment to make sure your designs will perform to the requirements, Inventor gives you the professional grade tools you need to get the frame design done fast.
The third tier of automation inside Inventor is achieved by using iLogic tools. Inventor iLogic technology is an easy to use and simplified coding interface that runs off the Visual Basic programming language. iLogic significantly reduces the complexity of programming by providing users predefined snippets of syntax. This syntax or pieces of code can be used to define rules to quickly reconfigure designs to meet the demands of customers for the customization of your products, allowing you to win more business from your customers because you can get the design to manufacturing out the door faster. Time is saved by not having to perform repetitive and tedious design and engineering tasks. Some of these tasks may include updating part properties, drawings, bill of materials, and making design changes by diving all the way into the root level of a model. If you have a look at the image on the slide, it's the one with the dark background and the Autodesk logo at the top. This is an example of a product configurator for conveyor that was created using iLogic. Now, let's say a client has come to us requesting a custom conveyor size. We can easily reference this form to make the requested changes. So you can see in the top level, we have some parametrics over here that can be adjusted. So we can change the length, width, height. We can also decide whether we want to include or exclude other components, such as a chute. And just below that, we have these intuitive manipulators that can be dragged in order to include extra legs or reduce amounts of legs and rollers for the entire conveyor. Once these settings are configured, the design will be created. Once the changes have been made, the model will update accordingly. And to expand on this, we could add additional buttons, one to update the drawing and dimensions, and another to update the bill of materials and export it to a document that can be used with an ERP system to generate a quotation. Now, let's have a look at some of this iLogic in action.
product configurators have been proven to save engineering time and accelerate sales growth of custom products. In fact, according to a study by industry analyst TechClarity, automating product customization with rule-based design is a best practice of top-performing manufacturers. So why isn't everyone automating product configurations? Setting up rules and making configurators accessible to sales reps and engineers often requires specialized programming knowledge, significant investments in development, and a lot of time. But with Autodesk Inventor, setting up and deploying a product configurator has never been easier. First, build the logic that drives the configurator. Inventor iLogic technology is specifically designed to take the complexity out of the programming, using parameters you've already defined in the model. Plus a huge library of code snippets, it's easy to define rules. Then create forms inside Inventor that provide a more intuitive front end to the configurator. Just select which parameters, rules, and iProperties you want to be available for configuration. They're automatically added to your form, no programming required. Then group them together on the form or separate them into different tabs for better organization. Finally, add text and pictures to provide instructions or to describe the parameters. Use your configured products downstream to create drawings, perform simulations, or generate machining toolpaths. This accelerates the design to manufacturing process, enabling you to shorten the delivery time frame and get the products to customers faster. With Inventor, you get all the benefits of a product configurator without complex programming knowledge or high upfront investment.
If you are a designer, have you ever been asked to make a change to a design for a new bid or customer request? This is an occurrence that happens often. Did you know you can empower others to do this work for you, even if they don't know how to use Inventor? iLogic enables sales members or other employees to leverage product configurators that are easy to use so they can do the work for them. Within the forms or configurators, engineering data, constraints, and ranges are pre-established, so users don't configure something that your company doesn't make. A salesperson using this form can be confident that the configurations that are generated from the form will produce a design that can be manufactured. On that note, this concludes the Inventor portion of the presentation. We will now dive into some AutoCAD Electrical. For those of you that do not know what AutoCAD Electrical is, it is a design software tailored for electrical control designers, purpose-built to create and modify electrical control systems. The application has a host of specialized functions that greatly increase productivity when it comes down to schematic and panel design. With this year's release, there are 3 notable new features to mention. The first being able to run a global search on the entire electrical catalog. Previously, you could only run a search for a specific electrical component in the category that it belonged to. For example, if you're looking for a circuit breaker, you'd have to first navigate to the circuit breaker category in the catalog and then run your search. The second addition is the update of manufacturer-specific content that has been added to the libraries. The content updates now include the new and most recent catalog data from Eaton and Siemens. Lastly, the icon menu has a new, refreshing, lighter look. Before we head over to AutoCAD Electrical to see how the application can be used to improve the quotation process, let's review a typical quotation process a company manufacturing control panels may follow. The first document received is the customer's request for a quotation. It includes the schematic design of what they want built and to be quoted on. On the slide, we have an example of 2 schematics, each representing an enclosure design. The information received from the schematics is then translated into the actual enclosure designs, where rails and switchgear are allocated accordingly to determine the correct enclosure range and size to be used. On the slide, we have 2 enclosure designs along with a drawing containing the front and side views. At this point, it is key to note that this is a manual process where the designs are either drawn by hand or using a standard CAD application like vanilla AutoCAD. From this information, a bill of materials list is then manually populated and plugged into an ERP system. A quotation is then generated, leading to a purchase order received from the customer. In the demonstration to follow, I'll showcase how AutoCAD Electrical builds upon this process. It can be used as an environment to build enclosure designs and quickly generate a BOM for quoting. So let's dive into this demonstration real quickly. Heading over to AutoCAD Electrical, at this point we have received our request for a quotation and will now build the enclosure design starting off with the rails. Just note there are different approaches to tackle the enclosure design. Whether you prefer to start with breakers or rails first, the process will be similar and can always be adjusted. To continue, the insertion of rails can simply be done by accessing the electrical database. Once in my database, all I have to do is simply choose the type of equipment I'd like to insert, and in this case it will be a DIN rail. Once I've defined my rail, all I have to do is simply pick and place where I'd like to insert it and draw a segment of that rail out and confirm. Now we would like to populate this rail with some switchgear or breakers. This is a similar process as seen with the insertion of the rails. I will access the electrical database once again, choose my type of equipment. In this case, I'm going to choose a 3-pole circuit breaker. And what I'm going to do over here is use something a little bit different. That's going to be the catalog browser. The catalog browser is a library containing all your electrical equipment. It can be used to search for a component or components using a series of fields. In this case, I'll just reference one of the item codes quickly, S203-C25, and run a search on that component. This pulls up the part assigned to the item code, as well as all its information that's attached to it. So we have the catalog number, manufacturer, and description. I can choose to insert this component. Head over to my rail, quickly define an insertion point, and place and define the orientation of the breaker. So this is the typical procedure that will be followed until a completed enclosure is created, simply by picking and placing equipment from the database. To fast track this process, I have a completed set of rails and breakers to the side. All that needs to be done is to actually get this information inside or into an actual enclosure. The enclosure can be obtained from the database by searching for the relevant item code. So I'll head over to my database quickly, choose the type of equipment. This will be an enclosure. And what I can do is quickly input some catalog data or head over to my catalog browser and do a search, but I'll just use this catalog item code SMS45A to quickly call upon my enclosure design. Head over to my workspace and place the entire enclosure. Now what I can do is simply copy the breaker information on the rails to the side, head over to my enclosure and paste. To fast track the process once again, I do have 2 completed designs. This will be A1A and A1B. So you can see these enclosures are already complete. They have all the necessary information. We have the exterior enclosure size. We have the rails that were embedded into the symbol itself. And then over and above that, we have a bunch of switchgear or breakers on those rails. And just below that, we have the bus bars. Okay, so we also have additional drawing. Um, the one for the front and side views. So we can actually create this very quickly once again by leveraging the AutoCAD Electrical database. All our standardized components will be stored here, and it is literally a case of picking and placing components to achieve or complete your design. And there you go, we have the front and side views, very easy to place, couple clicks, and that information will be populated. Now we have completed this information, and we'd like to actually use this information to create a bill of materials list by simply running a report. So AutoCAD Electrical has some nice reporting functionality, and I'll do this quickly. We can draw or use this tool to pull out a full bill of materials list for the drawings from our active project. Over here, I'm just going to define or choose the drawings I'd like to pull a bill of materials list of. Those were the completed designs A1A and A1B. A preview of the report is displayed. It lists all the equipment and quantities used in the designs. You can see we have all the item codes, descriptions, and quantities. And of course, this can be customized to your company standards or the bill of materials list that you'd like to pull out. At this stage, two things can be done with this. We can put this onto a drawing, or alternatively, we can save this to an external document such as a spreadsheet. And what will the spreadsheet be used for? The spreadsheet will be used to plug into our ERP system, where a quotation will then be produced. So what I'm going to do is quickly save this Excel spreadsheet in my BOM ERP folder, and that concludes the demonstration on how to actually quickly or leverage AutoCAD Electrical in terms of control panel design to quickly generate a bill of materials list that can be used for or plugged into your ERP system. Just to have a look quickly, let's lastly, before we shut down, let's have a look at the bill of materials lists that have been populated. So we do have the one on the drawing, and I'll show you the Excel spreadsheet that has been created quickly. So I can open the spreadsheet, and if you have a look, all the quantities as exported by AutoCAD Electrical will be there, and then we can just use this documentation or information to be plugged into our ERP system. Okay, so after that demonstration, that sums up this presentation. I'd like to open up the floor for any questions if anybody has. And what you can do is just type that out in the chat box. There should be a little chat box available for your inputs and questions. So I'll give you some time to do that. I know people may still be pondering about some questions to ask. Okay, so Tyrell Channing has posted a question. Can Electrical and Inventor be integrated? Yes, Inventor and AutoCAD Electrical can be integrated. To summarize that workflow, it's called electromechanical interlinking. And what this allows you to do is create your schematic design in Inventor and do your 3D modeling for your actual electrical equipment. And the benefits of this is you can quickly do routing by leveraging the schematic designs in AutoCAD Electrical. The two applications talk between each other, so it's a form of digital prototyping that will allow you to quickly do wire routing for your components in Inventor. And this will then allow you to actually get the wire lengths, because as you know, with the 2D schematic, you can't actually calculate a wire length because it doesn't have the real world application of it. And once you head over to Inventor, you can pull that information through, get the 3D design with the 3D version of the wires traversing through all the equipment, and that will then give you the wire length. So with standard AutoCAD Electrical, it doesn't have those. So we have a question by Anthony. Can we do HV switchgear panels with the standard AutoCAD Electrical? I would assume we should be able to do standard switchgear panels. I'm not too sure what you are referring to by HV switchgear. Okay, so we have a couple more questions. Is iLogic difficult to learn or set up? This question comes from Patrick. So to summarize, iLogic, you don't have to have any formal coding background. You may want to do some basic workshops that we conduct here at Modern OneSolve surrounding iLogic, and this will just give you the tools or options to get started. But in all honesty, for basic setups to automate those little tasks or common tasks that you may find in your design workspace, iLogic is fairly simple to use. Okay, yes, so high voltage switchgear. Yes, you would be able to populate those kind of or types of panels with AutoCAD Electrical for sure. I'm just laughing at myself because I didn't get that HV. Okay, so Pumlani has a question. I'm just scrolling through the chat to find it. He missed the last bit on an ERP linking of the BOM. Does it pull all components with related drawings? In terms of, is that for Inventor or AutoCAD Electrical first? I just want to clarify that. Would it be for Inventor? So what you can do, Pumlani, is iLogic allows you to achieve these customizations. So it actually broadens what you can do in the application. And for example, you could potentially have buttons that will allow you to have a button to export the bill of materials with the related drawings to a specific folder location. Okay, and then obviously that those drawings or the bill of materials list will then have to be plugged into the ERP system. Okay, so in the Inventor example, we didn't see that happen, but it can be done. Okay, so I see we have another question from Tanya. With the sales automation ability, I indicated that a person such as a salesperson or anybody actually can leverage iLogic using a product configurator to use it. I'm just reading through this question quickly. Yes, okay, so here's the part of the question. This is what Tanya had to say. Am I correct in assuming that the intelligent part logic library is set up first, in which case it therefore becomes a simple process for a salesperson to just pick up and drag those parts, which I'm assuming reduces the population of bill of materials or the time it takes to populate a BOM, which they can then just export onto the quote. Yes, so that is a good question, and it's a really nice functionality of iLogic is you can have these configurators pre-set up. And this is often the case is people enter and leave the company, so you lose that engineering knowledge. However, with iLogic, that logic is stored in the file, so anyone has access to it. So a representative from sales can actually do the configurations themselves using that configurator form, produce a bill of materials, and they can then use that for quoting. So they are no longer reliant on anyone early on in the design stages. And often the case is the sales representative needs to get a quotation out. They have to go to the design team and say, listen, guys, you need to do A, B, and C. With leveraging iLogic technology, they can actually do that work themselves by simply using the configurator. Okay, so Wally has a question. I may need some clarification surrounding that. If you got a plant layout on Inventor mechanical, can you import the electrical wiring into the layout? So I'm assuming if you created your plant layout in Inventor, you do the cable and harnessing in there. Can you export it back into AutoCAD Electrical? No, that is not possible. Okay, the two applications do speak to each other, but the schematic design won't be created for you from the 3D mechanical one. No, that is not possible. Okay, so Punlani has another great question. Could iLogic automate having put design limitations modification of an existing frame to suit design requirements? Yes, that is exactly what it can do. It's rule-based design. So you define the controls of your model first. And as we spoke about, this is done in the earlier stages of Inventor at the front end with parametric design. And then after that, you apply iLogic for rule-based design. And that allows the model to maintain its engineering data and specifications. So anyone that comes to the form can't actually make a design that you don't create or deviates from your engineering expectations that you set up.
Sorry, Yashin, can I just ask a question on Pomlani's question? It's Heinrich here. When you mentioned could iLogic automate having to put design limitations, are you meaning that iLogic will then create different iterations within that parameter set that you've created, or just automate what you're currently doing?
Yeah, so basically, if say you have a frame that exists, but then you have say a design that needs to be quoted, that requires just a couple of changes to what exists. Can I just say, okay, I need this dimension to be this, to be this, to be that, and then iLogic automates the existing one, or automates the modification of an existing one to create the design that suits, obviously having checked whether it even is feasible.
100%. Okay, so then the question was answered correctly. Thank you.
Yeah. Thanks. Guys, I need to go. Thank you.
Yeah, cheers, Pumlani. Have a great day. We have one more question by Patrick. Can iLogic be used to set up a basic quoting system for quick quoting turnaround times with regards to pricing on materials and machining time on similar items? And could you change materials on the same design and have it affect the price? So that is quite a task. And iLogic does allow you to do that, but to dive into the actual specifics of it, we kind of need to have a holistic overview of actually what you're trying to achieve and how you function as a company. So if you'd like to explore that any further, Patrick, I suggest contacting us. I know Helen is on the call. You can definitely contact her and we can do some investigation of how we may assist you with iLogic to actually get those processes set up and running. Okay, guys, so we are falling short on time. Hopefully we have answered all of your questions. I see there's a lot of buzz around iLogic particularly. If you guys wanted more information on it, want to learn how to use it, or want us to assist you in implementing iLogic technology at your companies, please feel free to contact us. Okay, and just any questions not answered in the chat, we will be in touch with you. Okay, so we do keep that constant communication. On that note, cheers guys and enjoy.